In today's lesson, we're going to be looking at topic 2.3, factoring trinomials. Now you'll notice that this is a bit of a longer video. Factoring is an essential outcome that we use throughout high school math. In this video, I'm going to be introducing you to 4 different methods for factoring. Ultimately, you're going to choose the one that works best for you. So you may not need to watch all of the methods. You might want to look at one. If it's not working for you, skip to another. Let's start with our learning targets. By the end of this lesson, you should be able to use algebra tiles to model the factorization of a trinomial. Again, you should be able to factor a polynomial by removing the GCF. Remember, that's the first step whenever we're factoring. You should be able to factor a trinomial with a leading coefficient of 1, factor a trinomial with a leading coefficient not equal to 1, factor a difference of squares, and then factor a trinomial with more than one variable. And then in the end, you should be able to write all of your polynomials in factored form if they're factorable. Start by reviewing algebra tiles. First example, we have x squared plus 4x minus 5. That will be my product, and my factors would be x times x to get x squared. And then we would have 5 positive x's, because x times positive 1 is x. And then in the second row there I have a negative x, so that's going to be a positive x times a negative 1. So my factors will be x plus 5 and x minus 1. And that gives me x squared plus 4x minus 5. Now you'll notice there's more than 4x's there. That's because these two will cancel each other out. So I have x squared plus 4x minus 5 equaling x plus 5 times x minus 1. Notice that x squared plus 4x minus 5 is my product, and x plus 5 times x minus 1 are my factors. Moving on to our next example, we have 2x squared plus 7x plus 3. Again, to get an x squared, I'm going to have x times x. And then I have 3 positives on the top. And along the side here, I need another x so that I can have another x squared. And then a positive 1. The next statement would be 2x squared plus 7x plus 3 equals x plus 3 times 2x plus 1. Remember that when we're factoring, we're just reversing the process of expanding. So we're going to go through a couple examples here and see if we can notice some patterns. So when I expand x plus 4 times x plus 1, that's going to give me x times x is x squared, x times positive 1 is positive 1x, 4 times x is 4x, and 4 times 1 is positive 4. Then these two middle terms can be combined, and I'm left with x squared plus 5x plus 4. What I want you to do is take a look at our factors and our product and see if there's any connections that you can make. Notice that 4 times 1 is positive 4, and 4 plus 1 is positive 5. So remember when we have x squared plus 5x plus 4, the 1 in front of the x squared is our a value, 5 is our b value, and 4 is our c value. What you should be noticing is that c is the product of 4 and 1, and b is the sum of 4 and 1. Next example, we have x minus 4 times x minus 2. When we multiply that out, we're going to have x squared plus 2x minus 4x minus 8. And again, we want to take a look at our a value, our b value, and our c value and see if we can make any connections. That negative 4 times positive 2 is negative 8, and negative 4 plus 2 is negative 2. To our third example, we have x minus 7 times x plus 7. Notice when I multiply this out, I have x squared plus 7x minus 7x minus 49. Those middle terms are the same values but opposite signs, so they end up canceling out and giving me x squared plus 0x minus 49, which then simplifies to x squared minus 49. This is actually a special case referred to as a difference of squares. And it's a difference of squares because we have two terms that are being subtracted, hence the difference, and both of those terms are perfect squares. So what do we notice? Well, we notice that our c value, which is the negative 49, is again the product of negative 7 and positive 7, and our b value is the sum of negative 7 and positive 7. Taking a look at our final example, we have 2x minus 3 squared, which is 2x minus 3 times 2x minus 3. In this case, our factors are identical, and so when we multiply them out, we're going to get another special type of trinomial referred to as a perfect square trinomial. Multiply out this polynomial, we're going to have 2x times 2x is 4x squared, minus 6x, and then plus 9. Look again at what we can notice. Well, if we look at our c value, we have a positive 9, and that's coming from the negative 3 times the negative 3. However, in the middle term here, it's not just adding the negative 3's because we also have that leading coefficient of 2. So in this case, our b value of negative 12 comes from going 2 times negative 3, which is negative 6. But if you notice, we've doubled that, so it's going to be 2 times negative 3. Trying to recognize a perfect square trinomial, what you will notice is that the first and the last terms are always perfect squares, and the middle term comes from doubling the product of your leading coefficient and your constant in one of your factors. Looking a bit further, I want you to consider the signs of our final product. Notice that in my first example here, I had x plus 4 and x plus 1. A positive times a positive led me to a positive product, so the same sign led to a positive product. And since both of my values were positive, when I added them together, I also had a positive sum. Next example, I had a negative 4 and a positive 2. Notice that when I multiply them together, I end up with a negative product. So if my product is negative, my signs are going to be opposite. And I had a larger negative value than a positive value, so my sum ended up being negative. Third example, again, I had a negative 7 times a positive 7, which led to a negative product of negative 49. And since my numbers were the same and the signs were opposite, I ended up canceling out to get a 0. For my last example, I had a negative 3 times negative 3, which led to a positive 9. And for my sum, I had a negative 6 and a negative 6, so two negatives added together, and I still had a negative sum. So when you're looking at factoring, recognizing how those signs relate to our factors will help us to decide whether we need the same sign or opposite signs within our factors. For this lesson, I'm going to introduce you to 4 different factoring methods. Now, if you remember from our learning targets, you're expected to be able to factor a trinomial with a leading coefficient of 1, trinomials with a leading coefficient that's not 1, difference of squares, and perfect square trinomials, along with polynomials that have more than one variable. Now, rather than teaching you each individual factoring method, I'm just going to show you 4 methods that work for all cases, but asking through these examples, my hope is that you'll be able to recognize some special cases that will actually save us a little bit of work. Right, so our first method is the box method. Now, when we're working with the box method, ultimately what we're doing is creating an area model. For each of these examples, I have the steps written along the side, but I'm going to talk you through them as we're doing the examples. So first example is 3x squared minus 2x minus 7. We're going to start by creating a 2 by 2 grid, which will be our area model. Corner, we're going to put our first term, which is 3x squared, and in the bottom right-hand corner, we're going to put our last term, which is negative 7. The challenge is to figure out what goes in those other 2 boxes. But what we're going to multiply a times c, so 3 times negative 7 is negative 21. And then I'm going to write out my factor pairs, so 1 and 21, and 3 and 7. In order to find these 2 terms, what I want to do is I want to find 2 numbers that multiply to be 21, or in this case, negative 21, and have a sum or difference of 20. And so that's going to be 1 and 21. Now, if you remember from before when we were noticing our signs, I have a negative product. That means that I'm going to have opposite signs, and I have a negative sum. That means that my bigger number has to be negative. So I'm going to have a negative 21 and a positive 1. Write those into my 2 boxes. This is going to be a 1x, and this is going to be a negative 21x. So we are representing the sum of these 2 numbers. Order doesn't matter, so I could have put the negative 21 in the top box and the 1 in the bottom box. Ultimately, my factors are still going to be the same. So our next step is to find our GCF in every row and column. So I have 3x squared and 1x. My GCF would be x. And on the bottom row, I have negative 21 and negative 7. If my first term is negative, I will always divide out the negative. So this would be negative 7. And then looking at my columns, I have 3x squared and negative 21x. So that would be 3x. And then 1x and negative 7, that's a positive 1. So my factors are going to be x minus 7 and 3x plus 1. How do I go about checking my work? Well, one method is just to re-expand. So multiply everything out. Other option would be to use substitution. So I could set up a left side, right side chart. I can come up with a value for x, so I'm going to let x equal 2. And then I put my product on the left-hand side, and I put my factors on the right-hand side. And then I would just sub in a value. So 3 times 2 squared minus 20 times 2 minus 7 would leave me with 3 times 4, which is 12, minus 40 minus 7 is negative 35. And on the other side, I have 2 minus 7, and 3 times 2 plus 1. 2 minus 7 is negative 5. 3 times 2 plus 1 is 7. That also gives me negative 35. Since these match, I know that I've factored correctly. Next example, we have x squared plus 7x plus 10. So again, I'm going to set up my 2 by 2 grid. I'm going to put the first term in the top left and the last term in the bottom right. And then I just need to determine the other two boxes. So in this case, my a value is 1. So 1 times 10 is 10. Writing out my factor pairs, I have 1 and 10 and 2 and 5. I notice that I have a positive product. So that's going to mean that I have the same sign. And I have a positive sum. So I want to have two numbers that multiply to be 10 and have a sum or difference of 7. That's going to be 5 and 2. And they're both going to be positive. So I can write positive 2x and positive 5x. Step is then to look for a GCF in each row and column. So x squared and 2x has a GCF of x. 5 and 10 has a GCF of positive 5. Looking at my columns, x squared and x has a GCF of x, and 2x and 10 has a GCF of positive 2. So my factors are going to be x plus 2 and x plus 5. Now this is one of those special case trinomials I was referring to where our a value is 1. And if you notice, our factors of x plus 2 and x plus 5, the 2 and the 5 give me a product of 10, and the 2 and the 5 give me a sum of 7. So if my leading coefficient is 1, I can just go straight to product sum. Moving on to our next example, we have p squared minus 25. Now that's not a trinomial, so we're going to rewrite it as p squared plus 0p minus 25. Notice that I'm going to have a product of negative 25 and a sum or difference of 0. So again, I can set up my box. My first term goes in the top left, my last term goes in the bottom right, and then I want to find two numbers that have a product of negative 25 and a sum or difference of 0. So that's going to be 1 and 25 or 5 and 5. Well, if I want a sum or difference of 0, that means I need the same numbers but opposite signs. So that's going to be a positive 5 and negative 5. So negative 5p and positive 5p. Pulling out my GCF, p squared and negative 5p has a GCF of p. 5p and negative 25 has a GCF of 5. P squared and 5p has a GCF of p. Negative 5 and negative 25 has a GCF of negative 5. So my factors are p plus 5 and p minus 5. Squared minus 25 is a special case referred to as a difference of squares. Notice that I have two terms separated by a subtraction sign, and both of those terms are perfect squares. So this is called a difference of squares. When we're factoring this, we can use a bit of a shortcut. Notice that when I square root p squared, that's going to give me a p. I put that at the front of each bracket. The square root of 25 is 5, but because I need to have opposite signs, one will be positive and one will be negative. For our last example, we have 4n squared minus 10n minus 6. Remember that whenever we're factoring, it's absolutely important that we first check for a GCF. So we can divide a 2 out of each of our terms. So that would leave me with a 2 as my GCF, and my leftovers would be 2n squared minus 5n minus 3. So we're going to use the box method to factor the part inside the brackets, but remember that GCF of 2 will have to follow us down to our final answer. Our 2 by 2 grid, we put 2n squared in the top corner, negative 3 in the bottom corner, and we're looking for numbers that multiply to be 2 times negative 3, so negative 6, and my factors would be 1 and 6 and 2 and 3. Again, I want to have opposite signs because I have a negative product, and I want to have a negative sum. So opposite signs, 2 and 3 would only get me to a 5 if they were the same sign, so I'm going to use 1 and 6. Since I have a negative sum, I'm going to have a negative 6 and a positive 1. So negative 6n and positive 1n. For the GCF in our columns and rows, so we've got 2n squared minus 6n, that's going to be 2n. 1n and negative 3 is positive 1. 2n squared and n is n. And negative 6 and negative 3 is negative 3. So my factors are going to be 2n plus 1 and n minus 3. Now remember, we have that GCF of 2, so that needs to be included in the final set of factors. So we're going to have 2 times 2n plus 1 times n minus 3. So what happens if you miss the GCF? Well, let's take a look. We would set up our box, but in this case, we're factoring 4n squared minus 10n minus 6. So I would put 4n squared in the top, negative 6 in the bottom. We're looking for numbers that multiply to be negative 24. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And we want a sum of negative 10. Again, they're opposite signs and a negative sum. So we would have a positive 2 and a negative 12. So we could put 2n and negative 12n. For GCF, we would have 2n and negative 6, and then 4n and positive 2. That would give me 4n plus 2 and 2n minus 6. But notice within each of the factors, I still have a GCF that I can pull out. So I can pull a 2 out of the first bracket, that would be 2n plus 1. Pull out a 2 from the second bracket, that would leave me with n minus 3. Notice that this time now I would have 4 times 2n plus 1 and n minus 3, which is not correct because my GCF is not correct. So notice that instead of having a GCF of 2, I have a GCF of 4. So this is not correct. Important to know that if you choose to use the box method and you miss pulling out a GCF if there's a GCF in the trinomial, your final factors will be incorrect. The method that we're going to look at is guess and check. Now with guess and check, what we're doing is we're looking at factoring the first and the last terms individually. So the coefficient for my first term is 3, and the factors of 3 are 1 and 3. My constant is 2, the factors are 1 and 2. Notice that I'm not even worrying about the signs right now, just the factors. Now, with guess and check is to now find a cross product that's going to give me a product of C and a sum of B. So let's try one out here. If I have 1 and 3 and 1 and 2 and I find their cross products, 1 times 2 is 2 and 3 times 1 is 3. Well, this looks promising because 3 plus 2 is 5. However, my product is negative, so that means I need to have opposite signs. So this will not work. So let's try another combination, 1 and 3 and 2 and 1. 1 times 1 is 1, 3 times 2 is 6. Now, if you notice, I have opposite signs and I want a positive sum. So if I have a positive 6 and a negative 1, I will get a sum of 5. So what I can do is I can set up a chart. Notice that to get a 3x squared, I'm going to have something x times something x. So that would be 1x times 3x. And then I have 2 and 1. When I multiply, x times 1 is 1x. 3x times 2 is 6x. Now again, in order to have a negative product, I need opposite signs and I want a positive sum, so my bigger number has to be positive and my smaller number is negative. Those signs are just going to translate over, so I'm x plus 2 and 3x minus 1. So my factors are now x plus 2 and 3x minus 1. I have a squared minus 19a plus 90. Notice again, this is a special case where my leading coefficient is 1. I'm going to start by listing the factor pairs for my first and my last terms. My factor pairs, I have a fairly long list here, but notice that I want to have a positive product, so that means I need the same sign, and I have a negative sum. Since my first term had a coefficient of 1, that's not going to be anything to worry about. I just need to look at the factor pairs for 90. So I need, again, something that has a product of 90 and a sum or difference of 19, and that's going to be 9 and 10. And notice again, I'm not worried about the signs. I'm just trying to find two numbers that would give me a product and a sum or difference. So I set up my chart. I'm going to have 1a and 1a and 9 and 10. 1a times 10 is 10a. 1a times 9 is 9a. Again, I need to have the same sign and I want negative sums, so these both have to be negative, and those just translate over. So my factors will be a minus 9 and a minus 10. Once again, this was a special case, so I could have just done product sum. I could have said, see, I have 81x squared minus 25y squared. So again, to write that as a trinomial, I would have 81x squared plus 0xy minus 25y squared. Using guess and check, I'm going to start off by listing my factor pairs for my first and my last terms. Example like this, there's more factor pairs, which means more combinations. However, you may have recognized that this is a difference of squares. Two terms, subtraction sign in between, and both terms are perfect squares. So that might help us pick out our numbers. If it's a difference of squares, that means we're probably looking for the same numbers. That would be 9 and 5. So again, I would do my chart off to the side, 9x, 9x, 5 and 5, and when I cross multiply, 9x times 5 is 45x, 9x times 5 is 45x. Looking at my signs, I have a negative product, so that means I want opposite signs. And I have a sum of 0, that means that they have to cancel each other out. So that means I'm going to have a positive 45 and a negative 45. So my factors will be 9x plus 5 and 9x minus 5. And because this is a difference of squares, we could use our shortcut, so we can square root both terms. And in the front of each bracket, root 81x squared would be 9x, so that goes in the front of each bracket. The square root of 25y squared is 5y, so that would go in our back bracket. And then we need opposite signs, so plus minus or minus plus. B, we have 21k squared minus 27k plus 6. Once again, we want to check for a GCF. In this case, our GCF is 3, so we divide out a 3, and that leaves me with 7k squared minus 9k plus 2. 3 is going to follow us down, but we're just focusing on the piece inside the brackets. So by listing our factor pairs, for 7 we have 1 and 7, and for 2 we have 1 and 2. Once again, I want to find two numbers that have a product of 2 and a sum of negative 9. So I could try 1 and 7 and 1 and 2. When I multiply those, I'm going to have 7 and 2. That will give me 9. So we'll set up our chart, 1k and 7k, and then 1 and 2. 1k times 2 is 2k. 7k times 1 is 7k. Now I notice my signs. I have a positive product, so I want the same sign, and I have a negative sum. So these both need to be negative, and those translate over. So my the factors of k minus 1 and 7k minus 2. And again, we need to remember that that 3 comes down, so our final factors would be 3 times k minus 1 times 7k minus 2. So once again, what happens if we miss the GCF in the beginning? Well, let's take a look. Start by listing my factor pairs. In case again, I have more examples to consider. I want a product of 6 and a sum of negative 27. So I'm going to use 3 and 7 and 2 and 3. Applying, I could try 3 and 7 and 2 and 3. That would give me 9 and 14. 9 and 14 will not give me 27, so we can try another combination. 3 and 7 and 3 and 2. That would give me 6 and 21, and that would work. So we're going to set up our chart, 3k and 7k, 3 and 2. 3k times 2 is 6k. 7k times 3 is 21k. Notice again, I want the same sign and a negative sum, so these both have to be negative. Factors are 3k minus 3 and 7k minus 2. Notice that that first factor can be factored further, so I pull out a 3. That leaves me with k minus 1 and 7k minus 2. Notice that in this case, I have the same factors. So with the guess and check method, if I miss pulling out my GCF in the beginning, I can still recover at the end. We're going to take a look at is decomposition. This is probably the most popular method that you see in most textbooks. It's also the method that will involve factoring by grouping as part of that process. First step in decomposition is to find the product of A and C and write out the factor pairs. So in this case, we're looking for the factor pairs of 18. Our signs, notice that we have a positive product, so we want the same sign, and we have a positive sum. So we want to find two numbers that have a product of positive 18 and a sum of 19. In this, it's going to be 1 and 18, and in order to have a positive sum, they both need to be positive. Factor pairs, we decompose the middle term. So we're going to break up the middle term into its two sums. So we're going to have 6x squared plus 1x plus 18x plus 3. And again, because we're adding, order doesn't matter. Here we're going to factor by grouping. So we're going to group the first two terms, group the last two terms with a plus sign in between, and pull out our GCF. So for the first term, our GCF is x, and that leaves me with 6x plus 1. And my last term, the GCF, is positive 3, and that's going to leave me with 6x plus 1. If it's factorable and I've done everything correctly, notice my two brackets should look the same. So I just factor out a GCF again. I'm going to have 6x plus 1, and my leftovers are x plus 3. Moving on to part B, notice I have m squared minus 7m minus 30, so my a value is 1. 1 times negative 30 is negative 30. Writing out my factor pairs, I have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Again, I'm looking for two numbers that have a product of negative 30 and a sum of negative 7. Since my product is negative, that means I want opposite signs. And if I have a negative 7, that means my larger number is going to be negative. So taking a look at my factor pairs here, I'm going to be using 10 and 3. I want a negative 10 and a positive 3. Step is to decompose those middle terms. So I'm going to have m squared plus 3m minus 10m minus 30 to factor by grouping. So we group the first two terms, group the last two terms with a plus sign in between. The GCF for the first set of brackets is m, and that's going to leave me with m plus 3. And for the second set of brackets, I have a negative 10, and that's going to leave me with m plus 3. Notice again that my brackets are the same. So m plus 3 is my GCF, and m minus 10 are my leftovers. Again, this was a special case, so if you notice, when my leading coefficient is 1, I could have just done product sum. Two numbers that multiply to be negative 30 and have a sum or difference of negative 7. For part C, I have 16h squared minus 1. Notice this is a difference of squares. I have two terms, a subtraction sign in between, and both terms are perfect squares, so I could use my shortcut, 16h squared minus 1. If I square root both terms, I can set up my brackets. The square root of 16h squared is 4h. The square root of 1 is 1, and then minus plus or plus minus. However, we're also going to take a look at how to do this using decomposition. Using decomposition, I need to create a trinomial, so that's going to be 16h squared plus 0h minus 1. My a and c values multiply to be negative 16, so 1 and 16, 2 and 8, and 4 and 4. I'll decompose those middle terms, so I'll have 16h squared plus 4h minus 4h minus 1. I'm going to factor by grouping, so group the first, group the second, and a plus sign in between. The GCF for the first bracket is 4h, and that leaves me with 4h plus 1. And the GCF for the second bracket is negative 1, which leaves me with 4h plus 1. The next step, my GCF is 4h plus 1, and my leftovers are 4h minus 1. Taking a look at our last example, we have 2x squared plus 10x plus 12. Again, I want to check for the GCF. My GCF is 2, so I'm going to be left with x squared plus 5x plus 6. In case I have a special case, my leading coefficient is 1, so I could just do product sum, two numbers that multiply to be 6 and have a sum or difference of 5, so x plus 2 and x plus 3, but we'll still show how to do this using decomposition. For decomposition, again, I'm looking for products of the 1 and 6, so that would be 6. I've got 1 and 6 and 2 and 3. I have a positive product, so I want the same sign, and a positive sum, so I want two numbers that are positive. So in order to do that, I would use 2 and 3. The 2 is just going to follow along for everything. So I've got x squared. I'm going to decompose that middle term. So x squared plus 2x plus 3x plus 6 to factor by grouping. So I have 2, and then in brackets, for the first bracket, I have a GCF of x. That leaves me with x plus 2. For the second bracket, I have a positive 3, and that leaves me with x plus 2. So now I have 2, my GCF is x plus 2, and then x plus 3. So what happens again if I miss the GCF? Well, let's find out. If I forget to pull out the GCF, then I'm going to be looking for two numbers that have a product of 24 and a sum or difference of 10. So listing my factor pairs, I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. I want two numbers that have a positive product, so the same sign, and a positive sum. So that's going to be 4 and 6, and they'll both be positive. Next, I decompose those middle terms. So 2x squared plus 4x plus 6x plus 12. And then I factor by grouping. In my first bracket, my GCF is 2x. That leaves me with x plus 2. And in my second bracket, I have a positive 6, which leaves me with x plus 2. My GCF is x plus 2, and then 2x plus 6. Well, notice that my second bracket can be factored further. So I'm going to have x plus 2, and then I can pull out a 2, and then x plus 3. Rearranging that, I would have 2 times x plus 2 times x plus 3. Notice that these are the same, so when I'm doing decomposition, if I miss that GCF, there's again a way to recover at the end. That we're going to take a look at is slip and slide. Now, slip and slide is a really great method if you're good at recognizing product sum. So for slip and slide, what we do is we take that first leading coefficient and we slip it over to the constant and we create a new polynomial. So we're going to have m squared minus 17m, and 18 times 4 is 72, so we put positive 72. Now I've created a polynomial or a trinomial that has a leading coefficient of 1, so I can just factor using product sum. I'm looking for a product of 72 and a sum of negative 17. So I again would start by listing my factor pairs. Factor pairs, I'm trying to find two numbers that multiply to be 72 and have a sum or difference of negative 17. Notice that I have a positive product, so I want the same sign, and I want a negative sum. So those are going to be 8 and 9, so negative 8 and negative 9. So I write my factors, m minus 8 and m minus 9. But remember that we created a new trinomial by multiplying the 4 by the 18, so we need to reverse that process. So we're going to divide each of these by 4 and then reduce our fraction. So m minus 8 over 4 is like m minus 2 over 1, and m minus 9 over 4 is m minus 3 over 2. The last step is to slide that denominator back to the front. Won't change anything, so I'm just going to have m minus 2, and here I'm going to have 2m minus 3. For the next example, we're going to start by checking for a GCF. In case our GCF is 3, so we're going to have 3 times x squared plus 5x minus 6. And this is already a product sum scenario, so we're looking for two numbers that have a product of negative 6 and a sum of 5. So that's going to be 1 and 6 and 2 and 3. Notice I have a negative product, so I want opposite signs, and a positive sum, so I want a positive 6 and a negative 1. So I can write that as 3 times x minus 1 times x plus 6. What happens if I miss the GCF? Well, let's take a look. First of all, we're going to slip the 3 over, so that's going to create a new trinomial, x squared plus 15x minus 54, and then I'm going to be writing my factor pairs for 54. Notice that I have a negative product, so I want opposite signs, and a positive sum. So I want two numbers that have a product of negative 54 and a sum of 15. Well, that's going to be positive 18 and negative 3. So I'll set that up first, x minus 3 and x plus 18. And now I need to divide out that 3 and reduce my fractions. So x give me x minus 1 and x plus 6. My factors are the same as the ones above, except I'm missing my GCF. So this would lead to an incorrect solution. So when you're doing slip and slide and you miss pulling out that GCF, you will end up with the incorrect factors. Look at C. Your instinct might be to say, hey, this is a difference of squares. I've got two terms, I've got a subtraction sign, but both terms are not perfect squares. However, maybe it is just in hiding. So we start by taking a look at a GCF. I'm going to pull out a 7, and that's going to leave me with a squared minus 9. Now we have a difference of squares. A squared is a perfect square, 9 is a perfect square, and we're subtracting, so we can use our shortcut. A squared minus 9 becomes a plus 3 and a minus 3. So my factors would be 7 times a plus 3 times a minus 3. No need to do slip and slide. Last example, again, we're going to start by checking for a GCF. In case our GCF is 3, so we're going to pull out a 3, and that's going to leave me with 6x squared plus 11x minus 10. The 3 is just going to follow us down, but we're going to do slip and slide for the remaining portion. So we have 6x squared plus 11x minus 10. We start by bringing that a value over, so we're going to have x squared plus 11x minus 60. And now I'm looking for two numbers that multiply to be 60 and have a sum or difference of 11. We start by listing our factor pairs. We have a negative product, so we want opposite signs. We have a positive sum, so the factor pair I'm going to go with is 4 and 15. I want a positive 15 and a negative 4. So that leaves me with x minus 4 and x plus 15. Now we divide out that 6 that we brought over and reduce our fractions. So we're going to have x minus 2/3 and then x plus 5/2. Those denominators slide to the front, and I'm left with 3x minus 2 and 2x plus 5. And again, remember that that GCF needs to follow me down. So my final factors will be 3 times 3x minus 2 times 2x plus 5. And remember that if you miss the GCF in the beginning, you'll have incorrect factors in the end. Now it's time to take everything that we've learned and put it all together. Before that, let's just do a quick refresher. When we're factoring trinomials that are in the form ax squared plus bx plus c, and the leading coefficient is 1, we can simply look for a product sum. So if I have x squared minus 7x plus 12, I'm looking for two numbers that have a product of 12 and a sum or difference of negative 7. In this case, x minus 3 and x minus 4. If I have a difference of squares, this is where I have two terms with a subtraction sign in between, and both terms are perfect squares. An example that I can square root the first term and the last term. The square root of the first term goes in the front of each bracket. The square root of the last term goes at the end of the brackets. And then I have opposite signs. So 5x plus 11 and 5x minus 11. A perfect square trinomial is just a special case where my factors are going to be identical. One way to recognize that a trinomial is a perfect square trinomial is that my first and my last terms will be perfect squares, and the middle term is double the product of my inner factors. So if I have 2x plus 3 and 2x plus 3, my first term will be the square of 2x, so 2x squared is 4x squared. The square of 3 is 9, so 3 squared is 9. And notice that my middle term is double the 2 times 3. So 2 times 2 times 3 gives me a positive 12. Whenever we encounter a trinomial where the a value is not 1, we're going to use one of those four methods we've talked about, the box method, guess and check, decomp, slip and slide. There are other methods out there. These are just the four that I've chosen to introduce you to. And then some last tips about factoring. First of all, whenever we are factoring, our first step should always be to look for a GCF. Remember that if you're using the box method or slip and slide and you forget to pull out the GCF, you will have the incorrect factors. If you're factoring a polynomial that is factorable and there are two factors, you have two options. Either it's a GCF, or it's a difference of squares, or it could be both. If there are three factors, always look for a GCF first. If your a value is 1, then it's just a product sum. If your a value is not 1, then you're choosing one of those four methods: box method, guess and check, decomp, or slip and slide. If there are four factors, check for a GCF, and then check to see if you could do factoring by grouping. So at this point, what I'd like you to do is I'd like you to pause the video, try these examples on your own, and then come back and check your work. Look at your work. Now, as I move through these examples, I'm not necessarily going to do them in order. I'm going to try to point out some of those special cases. So the first one we're going to look at is B. Notice that I have two terms, a subtraction sign, and both of my terms are perfect squares. So this is a difference of squares. So I can square root my first and last terms and set up my brackets. The square root of 121a squared is 11a. So that goes in the front of each bracket. And the square root of 100b squared is 10b. And then I'm going to have opposite signs. Moving on to C, I notice that this is a trinomial with a leading coefficient of 1, which means I can just do product sum. I want two numbers that multiply to be 56 and have a sum or difference of negative 15. So this is going to be a minus 7 and a minus 8. D, I first noticed that I can pull out a GCF. So I'm going to pull out a 2, and that leaves me with x squared plus 10x plus 16. Now I have a leading coefficient of 1, so I'm just doing product sum. I want two numbers that multiply to be 16 and have a sum or difference of 10. Notice that I have a positive product, so I want the same sign. So this is going to be x plus 8 and x plus 2. I have x squared plus 36. There is no GCF to pull out. I notice that there are two terms, so I ask myself, is this a difference of squares? Well, difference of squares would involve two terms with a subtraction sign, and this has a plus sign. If I write it as a trinomial, that would give me x squared plus 0x plus 36. I have a leading coefficient of 1, so I would be looking for two numbers that have a product of 36 and a sum of 0. Well, then in this case, there are no numbers that multiply to be 36 that have a sum or difference of 0, so this polynomial is not factorable. Notice that this is a polynomial with a leading coefficient of 1, and I have both an m squared and an n squared. So I'm going to be looking for two numbers that have a product of negative 42 and a sum of negative 1. Negative product means opposite signs, and I want a negative sum. So my factors are going to be m minus 7n times m plus 6n. Notice that 7n and 6n will give me that n squared. Again, I have a trinomial with a leading coefficient of 1, so this is a product sum scenario. I'm looking for two numbers that have a product of negative 20 and a sum of negative 1. Once again, I have a negative product, so I want opposite signs. So my factors are going to be b minus 5 and b plus 4. The first thing I notice is that I need to pull out a GCF, so I will pull out a 7, and that leaves me with x to the fourth minus 1. I have two terms, that means I have two choices. I've already pulled out the GCF, so I check to see if this is a difference of squares, and in this case it is. The square root of x to the fourth is x squared, so I can write this as x squared plus 1 and x squared minus 1. Now I check to see if I can factor any further. X squared plus 1 is not factorable. It's a sum of squares. I can't factor that, but x squared minus 1 is a difference of squares, so I can continue factoring. X squared plus 1, the square root of x squared is x, so I'm going to have x plus 1 and x minus 1. J, notice that I have a leading coefficient of 1, so again I'm looking for product and sum. I want two numbers that multiply to be 2 that have a sum or difference of 3. So my factors of 2 are 1 and 2. And I have a negative product. That means I need opposite signs, and I want a negative 3. Well, there is no way for my 1 and my 2 to get me to a negative 3 if they're opposite signs. So this trinomial is not factorable. That leaves me with 4 examples. In all of these cases, the leading coefficient is not 1. So for each of these examples, I'm going to use a different method. I'm going to use the box method. So I've got 3n squared plus 5n plus 2. So I set up my box. The top corner is 3n squared. The bottom corner is positive 2. And I'm looking for numbers that multiply to be 6. So I've got 1 and 6 and 2 and 3. Notice that I have a positive product, so I want the same sign, and I want a positive sum. So that's going to be positive 2 and 3. So I'm going to put a positive 2n and a positive 3n. Now I look for my GCF, so I pull out an n, I pull out a positive 1, I pull out a positive 3n, and I pull out a positive 2. So my factors for this trinomial are 3n plus 2 and n plus 1. Guess and check. But again, I'm going to start by looking for a GCF. In this case, I can pull out a 3. That leaves me with 2x squared minus x minus 6. I'm going to factor the first and the last terms individually. So I have 1 and 2, and then I've got 1 and 6 and 2 and 3. I'm looking for a grouping of numbers that's going to give me a product of negative 6 and a sum of negative 1. In this case, 1 and 2 and 2 and 3. So I set up my chart, x and 2x, 2 and 3. X times 3 is 3x, 2x times 2 is 4x. I want a negative product, so opposite signs, and a negative sum. So 4 will be negative, 3 will be positive. Those signs translate over, and then with x minus 2 and 2x plus 3. And again, I need to make sure that that GCF follows down. I'm going to use slip and slide. So I'm going to slip the 5 over to create a new trinomial. That's going to give me x squared minus 4x minus 5. I'm looking for two numbers that multiply to be negative 5 and have a sum or difference of negative 4. So x minus 5 and x plus 1. I need to divide out the 5 and then reduce. So that's going to give me x minus 1 and x plus 1 over 5. And then the last step is to slide that 5 back. So we're going to have x minus 1 times 5x plus 1. Example, I'm going to use decomposition. So my first step is to check for a GCF. In this case, I can pull out a 2. So I'm going to have 2 times 2n squared plus 5n minus 3. The The 2 is going to continue to follow us down, but we need to factor the piece in the brackets. 2 times -3 is -6, so my factor pairs are 1 and 6 and 2 and 3. I want a negative product, so opposite signs and a positive sum, so that's going to be -1 and +6. We write down the 2, and then in the brackets we're going to decompose that middle term, so 2n squared minus n plus 6n minus 3. We need to factor by grouping, so group plus. The GCF for the first bracket is n, so we're going to have 2n minus 1. For the second bracket, I have a +3, and that leaves me with 2n minus 1. So my final factors are going to be 2, and then 2n minus 1, and n plus 3. At the beginning of the lesson, factoring is an essential outcome. We're going to be using it throughout high school math and beyond. This is a skill that can be a little bit tricky to master in the beginning, but the more you practice, the quicker you'll get, the better you'll get. I've given you 4 different methods. Choose the one that's best for you and just keep practicing till you have it mastered. That's all I have for you today, guys. Have a great day, and I'll see you soon.